Hello everyone. In this video, I will be talking about the third learning objective of week 5, distinguish among population, sample, and sampling distributions. So I'll start with normal distribution. Normal distribution is a theoretical distribution of a sample, where the theoretical distribution means it shows a bell-shaped curve where the center of the distribution will be the mean and the variation of the distribution will be its standard deviation, and 99% of the values will lie within plus minus 3 standard deviation of the mean value. And the center of this normal distribution will be the average of the data, average of the distribution, and half of the data will lie in the right hand side of the distribution and half of the data will lie in the left hand side of the distribution. Okay, so let's see this example. So this is a distribution of IQ scores of 100 students. IQ scores, and you can see that this is a normal distribution. As I said, that it will be a bell-shaped curve and center of the data will be the mean value. So the mean IQ score was 100, and as I also said that the half of the data will be in the right hand side of the mean value and half of the data will be in the left hand side of the mean value. So average score is 100. We understand that half of the students get a score higher than 100 and half of the students get a score lower than 100. So this is one. Another point is I also said that 99% of the data will lie within plus minus 3 standard deviation. For this data set, the mean value is 100 and standard deviation is 15. So if we add 3 standard deviation with 100, I already said standard deviation is 15. So 3 standard deviation is 45. So if we add 3 standard deviation, it will be 145. And if we deduct 45, it is 55. So 99% of the students score between 55 and 145. Okay, now you may wonder that why we need to know about the normal distribution. Actually, these will tell you about the characteristic of data. Generally, when we have a sample, when we have a data set, we check that if the data is a normal distribution or not. Because if the data set is a normal distribution, we can understand that this data set will have these characteristics. That means its center will be the mean, half of the data will be greater than the mean and half of the data will be less than the mean, and 99% data will be within plus minus 3 standard deviation. So that will reflect a characteristics of the data set. Then population distribution, sample and sampling distribution. Population distribution is if we create a frequency distribution for the population, then it's a population distribution. In lecture video 1 for this week, we learned about frequency distribution. So the frequency distribution for the population is a population distribution. If we create a frequency distribution for the sample, then it's sample distribution. And if we create a frequency distribution of possible sample means, then it's called sampling distribution. Okay, keeping in mind that the sampling distribution is somewhat different from sample and population distribution, because sampling distribution is a theoretical distribution. So what does it mean? It means that, let's say you have a sample that has been drawn from a population. Now, it's not that this is the only sample you can draw from your population. It's possible to draw other alternative samples. Now, if you have different alternative samples, then each of the sample will have a sample mean. And if you create a frequency distribution for all these possible sample means, then it will be called sampling distribution. Okay, let me show you an example. Look at this one. We have 6 employees: Donna, Heidi, Jason, Jennifer, Mark, and Eddie. They are actually quality control employees. They find out how many products has defects. So Donna find out 1 defect, Heidi finds out 2, Jason 3, Jennifer 4, Mark 5, and Eddie 6. Okay, so this is our sample, and sum of this observation is 21, and average of this observation is 3.5. Now, this is our population. This is our population, and we want to pick up a sample from this population. Okay, And the sample should consist of 2 observations. Now look, since you have 6 observations and you want to pick up 2 in a sample, it's possible to draw different alternative samples. For example, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, or 2, 3, 2, 4, 2, 5, 2, 6. Different sample can be drawn of 2 observations. Now, if you draw all these possible samples, then they will be look like this: 1 2 1 3 1 4 1 5 1 6 2 3 2 4. So these are the all possible alternative samples. And if you calculate mean value of all these possible samples, then these are the mean values, and these are the probability that you pick up this sample 115 115 115. Now if you draw a frequency distribution for these possible samples, then it will be a sampling distribution. Okay. Now you might be wondering that why do we need the sampling distribution, right? So actually, here lies the reason that we should calculate the sampling distribution. This is standard error of mean. Look, what's the standard error of mean? Standard error of mean means standard deviation of sampling distribution. Okay. Standard deviation of sampling distribution is your standard error of mean. Now, theoretically, try to understand that when you have a sample and you get a sample mean, actually we assume that this sample mean closely reflects our population mean. Now the question is how correct this is, that a sample mean reflects our population mean. Then that's the reason we need to find out the standard error of mean. Now, if we have this theoretical sampling distribution and we find out the standard deviation of the sampling distribution. Now, if this standard deviation is larger, it means that the sample means differ from one to another, and there is a chance of higher error, because if sample means deviate much from one another, there is a higher chance that your particular sample mean will deviate from the population mean. However, if the standard deviation of the sampling distribution is very low, it means that all the sample means are close to one another, and it means that sample mean will closely reflect our population mean. Okay, so we estimate the sampling distribution to calculate a standard error of mean, and the standard error of mean reflects how closely our sample distribution reflects our population distribution, or how closely our sample mean reflects our population mean. So if you graphically look at this is our population distribution. We draw a sample distribution, the frequency distribution for our population. Then these are the possible sample distribution. Okay, so these are the possible samples, and you see that all possible sample has a mean. Now, if we draw a distribution for these possible samples, then it's a sampling distribution. Now look at the diagram below. These are the different sampling distributions. Okay, so for example, this one is when your sample size is 100, and this one when your sample size is 500, and this one when your sample size is 2500. So as larger the sample size, your sampling distribution will closely approach to a normal distribution. That is the central limit theorem that we'll be discussing in the next lecture video. Thank you.